Welcome back to another radar plotting video. Today we're going to try something a little bit different. We will be doing plot 11 from the Rapid Radar plotting packet, and we're going to kind of do like a speed plotting. So there won't be as much overdub, but see if you can keep up. So again, plot 11 from the packet. We have our ship's info. We're going 000 degrees true at 10 knots. Minimum CPA to maintain is 2 nautical miles, and MX is given as a time of 12:18. We have two targets to worry about in this exercise, target 1 and target 2. Now, target 1 and 2, we both have at 12 o'clock, 12:06, and 12:12. So target 1 at 12 o'clock is bearing 070.1 degrees true at a range of 8.4 nautical miles. At 12:06, they are bearing 069.8 degrees true at 6.9 nautical miles. And then at 12:12, target 1 is bearing 069.2 at a range of 5.4. Target 2's information is bearing the same every single timestamp. So between 12 o'clock, 12:06, and 12:12, target 2 is bearing 359.9 degrees true. Its range at 12 o'clock is 12.1, range at 12:06 is 9.9, and the range at 12:12 is 7.8. Now, because target 2 is barely outside of that 12 nautical mile range scale, I'm just going to go ahead and use a 12 nautical mile range scale, knowing that they might fall off the page a little bit, but I want to get the biggest ERM triangles I can. So with that 12 nautical mile range scale, I'm going to speed plot target 1 right here. Pause it if you need to catch up. But I go in first with all of my bearings at approximately what ranges they should be at, and then I go in with my dividers with a sharp lead to mark those exact ranges. Always make sure that you have a very sharp lead. Again, it just helps with precision. As you plot over and over and over again, you will have little mistakes here and there. The sharp lead helps mitigate that. Also, lately I've been walking around and noticing students with dividers that are very loose. Go ahead and take a screwdriver to your dividers and tighten them up, just to make sure that they don't move while you measure a distance and move it over on the piece of paper. Be sure to always label your points as well. When we do get into more multiple targets, keeping track of everything is very important. So right now, I'm just going to clean it up a little bit, and then connect my RML for target 1. Okay, so now I'm just going to create the line for my E, but I'm not going to go in and put the exact position down yet, because I might as well do that on both targets at the same exact time and save some time later on. So I'm just measuring that we are going 0, 0, 0, so I'm going to draw my E in the direction of 180, the reciprocal. Okay, so that's my line to eventually create my E. I'm just going to label that target 1, again, so I don't lose track of it. And now I'm going to go in and plot target number 2. Now, since the bearing is the same on every single range and bearing, I'm just going to draw that relative motion line across the entire page, because I know they'll have a CPA of 0 if they have a constant bearing and decreasing range. Again, target 2. Now I'm just going to go and put my exact ranges on. Now, since my scale doesn't reach up to 12.1 for that 12 o'clock, I am going to measure up to 6.1, and then on the 6 nautical mile range scale, measure out that extra 6.1. This only works if there is a center or 0 nautical mile CPA. So I created that R, 12 o'clock, going in with my 1206 at the same bearing with a distance of 9.9, and then my 1212 distance of 7.8. Sweet. Again, be sure to label everything. And now I'm going to go ahead and create my E. So if we're going 10 knots in the span of 12 minutes, we can essentially use the tenths rule to know that we'll move 1 nautical mile in 6 minutes. So with 12 minutes, we'll move 2 nautical miles. So again, we always measure E away from R in the direction of our reciprocal heading line. Okay, so those are my 2 E's. I can look at this information and see that both targets are very dangerous, and both are going to hit me, ballpark around the same exact time. So now I have to figure out which one I should be solving for. If we look at target 2 right ahead of me, that is a head-on contact. So they are very dangerous, but target 1 is also very dangerous. We want to solve for the one that is going to hit us first, which is ballpark of both of them, and then we want to solve for the one that is the most right. So target number 1 is the most right. We will be dealing with them. Now, since we're going to deal with target number 1 first, we have to figure out where their MX will be, 1218. Now, we could do the math and find their relative motion speed, or we can just essentially walk out their DRs. From R to M is 6 minutes, M to M2 is 6 minutes, and then M2 to MX is another 6 minutes. So we could just walk out that distance of MX. And while we're doing that, let's go ahead and do that for target 2 as well. Again, we're just walking out that distance to 1218 to write down our MX spot. Now, since we're solving for target 1, our MX of 1218 has to create a line from that to just outside our minimum CPA of 2 nautical miles. So you'll set your triangle up like so, creating that line tangent to the 2 nautical miles circle. Once you create that line, I like to label it new RML with the actual target number, again, just so I don't lose track. We're going to measure that angle and bring MX backwards to M, and essentially chop up this new relative motion line. Now that we have our backwards new relative motion line, we're going to measure E to R and swing out that R to create R prime. Now we can measure that E to R prime angle to get a new course that we could turn to. So we measure that E to R prime and then move it to the center to see what it reads out on the edge. I, in this exercise, got 078, but the computer simulator got 080 degrees. So if you're plus or minus 5 degrees with 080 degrees, you are 100% correct according to our tolerances. So this is still a question mark though. For target 1, if we turn to 078, we will be dodging target 1 by a CPA of 2 nautical miles. But we need to, after we find our speed, we need to double check both of this information for target 2 as well. So new speed measurement I got, my measurement was 0.75. We could do 60 D streets or do the tenths rule. And I got a new speed of 3.75 knots. And again, this is just for only if target 1 existed, what our new course and new speed could be. Okay, so now we're going to bring that e to r prime information, that new course, specifically that 078 degrees true. We're going to bring that information up over to target 2 just to double check that this new course satisfies both target 1 and target 2 for collision avoidance. So we simply just drag that e to r prime up to target 2 and draw it out. Now, the same way that we created our r prime originally, our r prime connected to our m2, we're going to do that whole process backwards. So connect your r prime to m2, and eventually you'll chop up this new relative motion line to be drawn down through mx 1218 as well. So it looks like our new relative motion line for target 2 with a new course of 078 is outside of our 2 nautical mile minimum CPA. So our new course of 078 degrees true works for both of these targets. Now let's check out if we did our new speed, 3.75 knots. So we just take that measurement from target 1, pop it over to target 2, and again, we're doing the same thing, that r prime connected to m2 and then drawn out to the mx. Now, since this target is a head-on collision, if we reduce speed, this vessel will still be a head-on collision, just slower. So the only answer is that we can change course to 078, but we cannot change speed.